Today we'll be reviewing what you learned about polynomials and polynomial division and learning what it means to factor completely. How do you feel about the last 4 Desmos activities? Have you felt like you've understood the math? So again, if you could be honest and write how you're feeling and how these assignments are working out for you, helping you out. So let's go ahead and look at slide number 3. For this slide, it looks like we have a polynomial that goes through the point -4, and then it passes through the point -3, goes up through the intercept 0, 48, y-intercept, and then comes down through the point 2, 0. So if you recall from previous assignments, if we have an intercept at x equals -4, that means we have a factor at x plus 4. And if we have an intercept at x minus 3, that means we have a factor at x plus 3. And this would mean we have a factor at x minus 2. Because remember, look here, it says x equals 2. How would we get the 2 to the other side with the x? We would subtract 2, so it would be x minus 2. All right, so let's write that equation in. We would write f of x equals x plus 4 times x plus 3. And then the last one, so here you see we have a parabola because it's just 2 factors, an x squared, degree 2 polynomial. And then our last one is x minus 2. So as you can tell, all our intercepts match. So they match exactly at those points, but our graph doesn't match. So if you remember, that means we have some a value in the front here that is going to change the direction of the graph. So I can also see that the graph is flipped over. That means our a value is going to be negative. You could see if I put a -1 here, that flips it, but it doesn't quite match. So we can use any point on this graph, which we already have as 0, 48. So I'm going to use that point to plug into this equation to try to determine what the a value is. So let's go ahead and look at that. All right, so here's our equation, and we're going to plug in point 0, 48. Remember, 0 represents the x values and 48 represents the y. So I can just plug in 0 for all the x values here. See, this will be a 0, this will be a 0, this will be a 0. And f of x is the same as y, and I'm going to put 48. So let's rewrite this equation. 48 equals a times 0 plus 4 is just 4, and 0 plus 3 is just 3, and 0 minus 2, it's just minus 2. Now, when we multiply, 4 times 3 is 12, times -2, that's -24. So we have 48 equals a times -24. Now, usually we write our variable on the other side, so I'm going to rewrite it as 48 equals -24 times a, just like this. All right, and from here it's just a one-step equation. I'm going to divide both sides by -24. And it does make sense that my a value is -2. So I'm going to go ahead and put that value into the equation. So if we put -2, our graph matches. All right, let's go ahead and take a look at slide number 4. Write the equation for the polynomial in factored form in the line number 2. Don't forget how to make the bounce and the bend. Yes, if you recall, a bounce is a degree 2 and a bend is a degree 3. So right here, we have -2, 0, and here we have a bend at 5, 0. So when we write this, we're going to write f of x equals, and it's a bounce at -2. So I'm going to write x plus 2 raised squared, because there's a bounce. So you could see it's matching that. And then it appears that it bends at the point 5, 0. So I'm going to write times x minus 5 raised to the third power. And that matches, so even our a value matches, which means, by the way, that our a value, if you said it's 1, you are right. Our a value is just 1 here. All right, let's go on to slide number 5. Slide number 5, write the equation of polynomial in factored form in line number 2. All right, so let's see. We have an x-intercept at -5. So that just passes through. So I'm going to write x plus 5 there. And you could see that's just a line, and it's going through the point -5, so that totally makes sense. And then it passes through the point -1, so I'm going to write x plus 1. And then it goes up and back down through the point 2, 0. So I will write times x minus 2. And then it looks like it goes through 3, 0. So I have x minus 3. Okay, but again, our graph, the a value does not match. So I'm going to write this equation down as y equals to a times x plus 5 times x plus 1 times x minus 2 times x minus 3, and I will choose a point that is already given to me on this graph, and it looks like 1, 8 right here is given on the graph. So I'm going to choose 1, 8 and plug it into my equation and find my a value. So let's go ahead and do that. All right, so here we go. We have our equation, and we are going to plug in the point 1, 8 because that's what was given to us. So let me just, okay. So my y is 8 and my x is 1. So I'm going to go ahead and say 8 equals a. And now all my x's are 1. So this is going to be 1 plus 5 times 1 plus 1 times 1 minus 2 times 1 minus 3. And then I'm just going to simplify this. So that is a equals to a times 6 times 2 times -1 times -2. Let's multiply those numbers out. 6 times 2 is 12, and 12 times -1 is -12, and -12 times -2 is positive 24. Is that right? Well, we'll find out once we plug that into our a value. So 12, 24. All right, now I'm going to divide by 24. And so a is equal to 8 over 24. And of course, we can reduce that. What is common between 8 and 24? Well, we know any even number shares 2. So we could start off by 2. So 8 divided by 2, 24 divided by 2, that is 4 over 6. And we can still divide by, oops, not 4 over 6, 4 over 12. And we can still divide here by 2, but I could see that 4 is common with 12, so I'm going to divide by 4, and I get 1 over 3. If you saw that, 8 goes into 24 3 times, it's 1/3. So our a value is 1/3, and obviously, if you made a mistake, you can easily check it, because once we enter our a value to the graph, it would not match. So if it matches, it means we did it correctly. So I'm going to put here my a value is 1 divided by 3. And it looks like that is correct.